Alrighty, up and running again. So this is lesson 4 plus a brief presentation before each lesson set to try to solidify our understanding of what we're looking at and in some respects, how we might start to use it in kind of preliminary fashion. The Latin, I hope I'm pronouncing your name right. Can I see that? Well, let's put it over on my Rene Descartes. Here it's on the cart now. Hopefully that's not too blurry, but that's my email. I'm happy to chat. Sound like you're a mathematician yourself, and yeah, Zoom, maybe do a little Zoom session, but it's Jim Vollinger, J Vollinger at nmhschool.org. I tried to put it on my profile, but not that, I don't have a lot of facility with computers and I don't spend a lot of time. So the only reason I'm uploading here is during COVID. Whatever I was using to begin with took me more than a half an hour to upload from class to class. And oh my God, what a nightmare. So YouTube's very helpful. All right. So in some of your commentary on the channel, I've written back to you with that address, and hopefully you can see it. I didn't mispronounce your name. So I just want to do a couple of quick context problems, and then we'll talk about it. So write the equation of a line that passes through 0, 32, and 100, comma 212. All right, you pause the video and go ahead. And I'm hoping that you wrote something like 32 to 212 is 180. 0 to 100 to 100 units of change. X minus 0. I don't have to write the 0, obviously, plus 32, but keeping it in the form that we've been learning. Let's do that for a moment. And let's reduce 180 over 100, which should come out to 95. Be embarrassing if I made a mistake here because I'm not doing any computation. I've done this problem a lot, obviously. And then I asked my class to change the lettering. Yep, change the lettering. Well, I hope people would, come up with the fact that I'm giving Fahrenheit as a measurement of centigrade. All right, because this simply becomes C. And now if you're overseas, well, you might know the temperature if you're coming out of the USA and you go somewhere else. And we're hearing about all these temperatures. Actually was in India last year and 45 degrees. So what do we get? Well, we drop the 45 in. 5 into 45 is, and these are degrees, by the way. And degrees and degrees cancel. And I just get the number 9. I've got degrees here. I've got degrees here. I'm dividing. Well, they fit into each other nicely. I've never seen a degree run around. Okay, but anyway, we got rid of them. So we got 9 times 9 is 81 plus 32. And then I know when I go out, it's 113 degrees Fahrenheit. Okay, it's a nice warm day. All right, so just a little context using just linear function for something real basic. And used to play a lot of soccer, and now I'm happy to just be walking around. Well, let's say I take a ball and it's 3 feet high. I'm in a very controlled environment here. So I put a little power into that ball and it goes up to 67 feet as a maximum. Maximum 67 feet. Yeah. And yeah, I found out, I take a measurement. It came exactly straight down at 4,3. So 3 feet high after 4 seconds. And then we'll find out when it hits the ground, and we'll do it all pretty quickly. So pause the video, see if you can write the equation. The practical demand is, it's a parabola, right? So I'm looking at parabolic, and the practical domain is 0. That's the time it was, and it was above ground. I don't know when it hits the ground, so I'm going to find that out later on. And that's the practical, because I don't think the ball went through the ground. And so we have this practical domain. All right, so what is it? Well, there's a pattern. Where does it emanate from? I think if you said pin the tail on the donkey, I think you better go right there. So you got to highlight that, x minus 2 squared. We'll change the lettering in a little while. Gets us a max. This is a max. If I ever ask you for maximum or minimums, please give me the y values. All right, and rise over run squared, well, I went from 67 to 3, or I went from 67 to 3 here. Maybe it's easier, that's why I put this there. I go down 64 feet. And the time it takes from 2 to 4 is, well, if I put a 4 in, I hope you can see what it changes by. 4 minus 2 is 2 squared. It changes by 4 units. I don't want to go up 4 units. I want to go down 64, so I make this conversion process. And if I write this out, I get my y values by minus 16x squared plus 64x plus 3. Wow, I get some interesting numbers. In fact, if I throw 0 in, I get 3. Oh, works there. And if I throw a 2 in, I get minus 64 plus 128 plus 3. I get 67. Geez, it even works for that. And I'll guarantee it'll work for a 4 as well. So now let's change the letterings into functional notation. And I got a timeline and I got height. So my height as a function of time is minus 16 t squared. Oh, a little force of gravity here. 64 t. Oh, little initial condition of 303, little initial condition and initial force on the ball. And that ball went right into the space. And, oh no, it didn't, shucks. Did not escape the force of gravity. Got pulled back down. Imagine that. I got this gravity force pulling things back down, this initial force going up, and I wasn't strong enough. Oh, another failure. All right, but after I played ball, I decided to get a pizza with the buddies. And so we did Newton's law of pizza warming. Where the oven temperature I was watching, I was very much impressed by the folks making my pizza. So I watched them from get-go. They put the ingredients on it and they did the flipping it around. And after 5 minutes, they put it in the oven. And I got no idea what the temperature of the ingredients were coming out of the oven or whatever, but we'll say 40 degrees. And by golly, you know, I asked the guy making the pizza, Giuseppe, and I said, hey, you know, the pizza? Yeah, the pizza. He said, well, been in the oven for 11 minutes and he knew it was 320 degrees and he's made a lot of pizzas. And the oven temperature was 350. So what's the equation? Temperature as a function of time. I'm not going to do T of T. So we'll just go X and Y. So Y equals. Well, how am I going to go about this? I think I got to show those temperatures. And I think the most important one is 350. Yep. And then I asked myself, well, how do I get to 40? Well, I got to go down 310. You know, I don't always go down 310. No, that's variable. It's really changing all the time. In fact, the next time I look, I don't go down 310. I actually go down 50 to 20, 30. I go down 30. So this is actually down 310. This is down 30. And these are degrees. And degrees cancel. So that's just a generic number. And minus 30. I think I can reduce the zeros here, and it looks like I'm getting this decaying differential. So this is a differential, and it is decaying. Yeah, that pizza's starting to get hot. And of course, I got to get my timeline in here. 5, so why don't we go x minus 5 minutes, because that makes it 0. Anything to the 0 is 1. Take 310 away from 350, you're at 40. And from 5 minutes to 16, 11 minutes elapses. And now we've got a record of temperatures in this little situation. I'll do one more. You know, just do the Three Stooges. All right, I like the Three Stooges. You know, Mo, Larry, Curly, I'm starting to look like them. All right, here we go. So my hand is at a certain height. And I know Mo gets poked in the eye, so I got to do this like. Oh, okay. So how many times did I do that? I don't know. My hand was at a certain height, and I know it just kept going up and down and up and down and up and down. I don't know how many times I did it, and usually it trails off with rotator cuff problems. So if I step back, all these should be the same, maxes and mins. And let's just say that I've been talking for 3 minutes. And that height, I'm getting shorter, 68 inches, so 68 inches, and it's down to, that looks to me to be about 8 inches, so let's go down 60 inches over here. And how long did it take to do? Whoa, okay, wait a minute, I can do this. Whoa, let's say that takes 4 seconds. 4, 8, 12, 16, on here, 16, 18. So after 18, so it takes 18 and 3 is 21. So after 21 seconds, I'm here. All right, so how do you write this equation? You got no clue. You haven't even studied the sine function yet. But I'm just going to show you that we're going to learn it. And it's actually got a linear component. See if you can spot the linear component and at least a little bit of the thought process. All right, so what's the most important height? It's the one I started in the middle. And in the middle was what's between 60 and 68, 64 is the most important. And I'm just going to write this as a sine function. Sine function measures height in a unit circle. If that's 0, then that's pi over 2. And then this is pi. And then this is 3 pi over 2. Doesn't hurt for you to get your brain to hear this. And that's 2 pi. And I know it comes from something you've never seen before. Circumference equals 2 pi r. And if r is 1, it's 2 pi all the way around, halfway is pi, so on and so forth. And so at pi over 2, I'm at a maximum height of 1. Just keep that in mind. So how do I get from 64 to 68? I go up 4. It's a sine function. I'm going around the circle, so that's 2 pi to here. 1 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi. 4.5 revolutions. It takes me how long? From 3 to 21, 18 seconds. Oh, how lovely. Of course, we made it canned, right? We went 4, 4. Okay. And I got to make a 0 out of 3. So that's x minus 3. Then I got to turn 3 into an angle. And I'm going to use pi over 2, which is really 90 degrees in another language system. And that's that equation. Didn't take too long to write. All right. So now we do lesson 4. 47 problems, maybe more. Looks like it's 47 again. Very similar to the last lesson set. Repetition is our friend. And I am wide awake right now. I got a good night's sleep. So if you want to go back to lesson set 1 and lesson set 2 and lesson set 3, I shouldn't have to explain what I'm even asking you to do because YKTD. You know the drill. Okay, equation of a line, minus 5, 17. X plus 5 plus 17. Put a 1 in, you change by 6. And then you got to get from 17 to 24, which is a change of 7. And you can just leave it like that, put equals Y. Okay, so we got that one done. This one here is put it in the AX plus B form. So minus 3/7 X. Minus times a minus is plus 6 over 7. 9 is 63 over 7. And that becomes Y equals minus 3/7 X plus 69/7. Looks like I had a couple of positives and positives. Much easier to do. All right, you're pausing the video each time. Now we're naming 3 coordinates. What do I see? I see the first coordinate is 8 gets me 2 because I make a multiplication by 0. If this is changing X, then why don't I change that X by 7? If this is the change in Y, why don't I go down 20? Why don't I plug 22 and negative 38 in just to show you that it works? 22 equals a Y value minus 38. Let's see if that's actually working because I don't want to write equals if it isn't. 22 minus 8 is 14. Oh, what a coincidence. 14, multiple of 7, goes in twice. Oh yeah, I'm going down 20 twice. I think we've shown that it works. All right, next problem. I don't like dividing by negatives. 43x. Oh, let's find out what the answer is approximately without. So from a graphical standpoint, minus 23x minus 15. So let's make that our x-axis. Let's make this minus 15. Minus 23 is almost vertically. Rotator cuff problems. 100. Oh my God, 100 up there. Oh God, 100. Yay. And it's going up quickly too. Oh, this one was going down. This one's going up quickly. It's way up there, up quickly. So then these things are going to intersect at some negative number. I'll say -5. God, I don't know. Got no clue. Just a real random guess. Add 115 over here. Oh, I'm way off. No, I'm not too bad. Two, so a little bit, 2.5. Wait a minute, it should be negative. Oh, yeah, minus 115. See, that's why I did the graph. I just caught a mistake. So negative 115 over 43, close. This is closer to -3 than -2. And I said -5 just out of the blue. All right, so I'll go with that. No mistake. All right. Make some room here. This one here, -3/7. Let's get an approximation for that one too, because I want you to know that these equations are the intersections of two graphs. And let's get a quick approximation for this problem. So -2 over 7 down 3 over 7 down 3 gives me a line that looks like that. -1 be there over 5 and up 4. If that's 7, I'll say that's 5 up 4 right about there. All right, so I'm looking for a small negative number, and if I don't get a small negative number, then I did something wrong with one of those processes. So I'm going to multiply by 35. Right, if you're just coming into lesson set 4 without having done the other lesson sets, go back to those. It's 5 minus 15x minus 70. 7, 28x minus 35. Let's get positive x's, so let's bring the 15 that way. 38, 43x must be some. Thought that was what I had the last time. Add 35 to this, and I get minus 35 on this side. And so minus 35 over 43, there's my small negative number. I'm assuming I'm right. Move on. Okay. Next problem. Okay, perpendicular, 5x plus 4y, 4290 through -28. Through -28, I can immediately write this. There, -2 gets me 8 for my y, and I know my answer is 4 over 5. Without doing the work, let's do the work. So 5x plus 4y equals 4290. We don't care, that number doesn't mean anything. 4y equals minus 5x. My y value is minus 5 fourths x plus da 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 da. If that slope is down 5 over 4, I won't do this too many more times, then the perpendicular is going the other way. And if this one is down 5 over 4, so down 5 over 4, then this one should be, the up one should be over 4 and up 5. Negative reciprocal. Okay. All right. So now let's change this. Getting through this a lot. Thank goodness. Breakfast awaits. Yeah. So what have I got here? F of -5. So I'm going to plug -5 in. -5. And I remember that was a -4. I'm lucky. So that's 15 over 2 minus 8 over 2, which is 7 over 2. Right, it's taken care of. If f of x equals 11, then I can replace f of x with 11. It's another name, may be written as. So I'm writing f of x is 11. So now I'm going to add 4. I'm going to multiply by 2. And I'm going to divide by -3. So minus 10. All right. 3 to the what equals 81? Well, I know 81 is 3 times 3 times 3 times 3. It's 3 to the 4. So therefore, I know I got to at least do that to get that number. And if I want to put it in the denominator, I reciprocate. I take 3 over 1. It becomes 1 over 3 4 times. And I get that. Square root of 75. We just started doing these in the last lesson. Says the square root of 25 times the square root of 3. Which is equal to 5 root 3, and from the last set, root 3, 1.73 as an approximation, so the symbol for approximation is that. Okay, we just started using factoring. So this could have been written as root 2 times root 6 is root 2 root 3. Root 10 is minus root 2 root 5. And so this becomes 2 root 3. And this becomes minus 2 root 5. And that's kind of like saying 2x minus 2y. You can't put them together. These are not the same square roots, so you can't add them. If all of a sudden I had 12 root 3 plus 7 root 3, Well, that's a different matter. That's 19 root 3, just for a little clarification. All right, you haven't seen a conjugate. I haven't even mentioned the word yet, but you have started working with I, and mathematicians don't like I in the denominator. I don't know why, but let's find out. Let's read two numbers here. Let's read this number here, and let's read this number here. I know this one. This is whatever I is. I got half of it. You tell me how you want to describe that. All you can do is basically say 2 divided by an imaginary. No field for size, magnitude. So we like to get the i's out of the denominator. And the way we do that is to use what's called a conjugate. The conjugate of 4 minus 7i is 4 plus 7i. Again, you don't have to be going to become an engineer. These are showing up on your SATs. And if you want to do a little better, then we're going to practice these. Okay. And so what do I get in the denominator? I guess I got to do this up here. Sorry to take the time. 4 minus 7i, but you can always go fast forward things. So 4 plus 7i, and this is 4 plus 7i. Obviously, I'm dividing by the quantity 1, so it doesn't change the size of the fraction. 3 times 4, 12. 3 times 7i, 21i. 2i times 4, 8i. 2i times 7i, 14i squared. We know that I squared equals -1 from previous discussions. 4 times 4 is 16. 4 times 7i is 28i. Minus 7 is minus 28i, so I won't do this in the next lesson set. Minus times a minus is minus 49i squared. So I'm going to doctor this up right here. 14 times -1 is minus 14. 12 minus 14 is minus 2. 21i plus 8i is 29i. Beauty of the eraser. Plus 28 minus 28i cancels, and they will always cancel. That's why we're doing this. I squared changes the sign of what's in front of it, makes it positive. 16 plus 49 is 59, and 6 is 65. I hope I just did that right, 65. All right, that's how bad my memory is. Hence, retirement. All right, so we're counting the number of factors of m. M to the 12 over m to the 15 could have been m to the 12 over m to the 12 times m to the 3. M to the 12th goes into m to the 12th, so I get 1 over m to the 3, which is also equal to m to the minus 3, but we will prefer that form throughout the semester. All right, once again, folks have trouble with long division in Algebra 1. Well, I think if we practice this first, maybe we'll understand why we put things in columns and where things come from. We do it, well, we can't do it in our head. I can see what it takes to get x squared minus 8x. It takes x minus 5. Okay, and I know that when I multiply this, I get 15. And I want to get to 10, then I better go down 5. So I need to go down 5. But the problem is it's being multiplied times x minus 3. Let's alleviate the problem and divide by x minus 3. All right, that's probably going to look awkward to you for another week or so. But, you know, you're pausing the video, you're trying. And I can always check to see if it works by using the critical number, 3, plugging it in. 9 minus 24 plus 10 is 19 minus 24, which happens to be minus 5. Oh my, what a coincidence. I wonder why that's true. We'll figure out as we go through the semester. And the folks in class will get a chance to get that wrong and then get another one like it and try again. But not in the videos. So if f of x is plugging in the number 11, then this input is the output of 2x minus 3. All right, so there's a shortcut. So therefore, we've got 14. We've got 7 as an answer. Now, let's actually find the inverse of f of x. So f minus 1 of x is the inverse operations. So x plus 3 divided by 2. And let's plug 11 in. 11 plus 3, 14 divided by 2. By golly, it was 7. So inputs here, X gets me Y. What's the inverse of X gets me Y? Changing the X's and the Y's, and Y gets you X. So this X is actually the Y value. It's actually the Y value on this side, and Y value of 11 means you're solving an equation. So we're starting to put a little context in with these mechanics. And we got a whole semester now. We get to talk about that for another 55, 60 days. Vertex, -3, 7. Then I know I've got X plus 3 squared plus 17. And I know 17 to 6 is going down. So I got a cup shape down, and my vertex is -3, 17, because 0 squared is the smallest area you can get. If you put a minus sign in front of it, it becomes maximum. All right, and what makes 0 squared up here? Plugging in. All right, so I'm now going to plug in the second number, 10. 10 plus 3, oh, -3 to 10 is 13 units of change. Wow. Oh, there it is. Yeah. So I've got 13 units of change squared. It's 169. I happen to know that, I think. Yeah, so 15 squared, 169. I don't want 169 units of change because I want to get from 17 to 6. 17 to 6, for goodness sake, 17 to 6 is down 11. So I think that's that equation. What do I have to do to a 1/5? I got to flip it. And I got to reciprocate, and I got to cube. So writing 2x squared minus 10x as a product. Let's see how we doing here. Marching right along, getting some practice in. Yeah, you can see that. So minus 2x squared minus 10x as a product. Take out what's common. 2 is common to the integers, and x is common to the variable terms. All right, so 2x times what? X gets me 2x squared. 2x times what? Minus 5. There's my product. Whoopee. And what's that called in math? When you make sums and differences into products? Factoring. All right, what's the vertex? Well, I got a cup shape up. I can see that. I need minus b over 2a for the x value. So minus b is -6 over 2 times a is 6, so -1. So -1 is that. And now I just got to get the y value. So I plug it in and I get 3 minus 6 minus 7. There's my 2 to 1 opposite relationship. It's a 3 to 1 in the cubic. And so I get -3 minus 7 is -9. And there's your vertex. All right. So this one here, I'm going to write in the ax squared plus bx plus c format. So the first thing I'm going to do is rewrite it as -2 x minus 3 squared and put the 5 at the end. All right. Now I'm going to do -2. I am going to square the binomial, which is x squared minus 6x plus 9. I double that product for the interior term, and then I'm going to add 5. So my final answer is -2x squared, minus times a minus, positive 12x, -18 plus 5, -13. There's your expansion. Let's check it real quick with a number like 4. 4 minus 3 is 1, 1 squared is 1, 5 minus 2 is 3. 4 gets me 3. If a 4 down here doesn't get me 3, then I cannot say they're equal calculations. 4 minus 32. 4, 48. Minus 13. Okay, help me out, Lord. 48 minus 32 minus 13 is, I made a mistake somewhere. Where did I make my mistake? 4 squared, 16, minus 32. 4 minus 3, 1 squared, minus 2 plus 5, 3. Okay, I threw a 4 in there. So 4 squared 16 minus 32 plus 48 is, oh, I didn't make a mistake. I just, 16 minus 13, 3. Okay. Well, brain must be getting a little tired even with a night's sleep. Okay, getting a good workout though. When you're in the weight room and your arms get tired, guess what? You're giving your body a good workout. Not that I do it anymore. I don't. But you want to work your brain? do this. Okay, so now what have I got? Standard form. Okay, from previous videos, we should know that we're looking at the XY axis. Intercept, so 4 goes into 24, 6, so this goes from 6, 0, and I know it should be coming down, because when you add two numbers that add up to a constant, they both gotta go up. Oh, they gotta go, yeah, one's gotta go up, one's gonna go down. There we go. 4 goes 36, 3 into 24, 8, so 0 gets me 8. There we go, so yeah, it's going down. Using the intercept, standard form. All right, factoring, well, I know I need a 2A and an A. If I put a 5 in here, that's 10. 10 and 1 doesn't work, so I better put the 1 over here and the 5 there. Feels like I did this problem yesterday. I want a minus, so minus and a plus. Okay, you gotta just get practice. French work. Just gotta get practice. You're pausing the video here. All right, I can see my answers. One of them 0. One of them 7/4. One of them is minus 5. So length times width times height equals volume. And if I get rid of one of the dimensions, switch the box, get rid of the height, makes it 0. I can make it 0 by plugging in -5. Minus 10 plus 10 is 0, and 0 times anything is 0. That's the concept. All right, minimum. Minimum means I'm looking for the vertex again. So minus b. 12 divided by 4 is 3. So I plug in a 3, I should get a 2-to-1 ratio. Double that means that should be 18. Yeah, looks good. And minus 5, so the vertex was minus 18 minus 5, minus 23. And I march on. Y-intercept. Well, y-intercept means you're plugging 0 in for x. That's why I asked the question. What's the exponent you put on top of a 3 to get a 9? That's a 2, and a 2 plus 8 is 10. So 0, 10 was the y-intercept of that graph. Should I graph it for you really quickly? Now, we'll get more practice with that later in the term. All right. F of x and g of x. I'm going to do f of g of 2 again. For your SATs, the question may have come at you that way, probably would. So I got to do g of 2. I put 2 in to the g function. And I get 6 minus 11, which is -5. I then take -5 and put it into its function, its calculation. -5 minus 5 is minus 10 squared is positive 100. So f of g of 2 is equal to 100. The inverse of g. Well, the inverse of g is written this way. And I basically want to solve equations. And if I solve equations, I got to add 11 and then divide by 3. And I can check it by putting the number 4 in. 12 minus 11 is 1. A 4 gets me 1 in the g function. Then in its inverse function, a 1 should get me a 4, or I've made a mistake. I plug a 1 in. 1 plus 11 is 12. Divided by 3 is 4. I move on. All right, we're going to do a couple of name those tunes. I got to be careful. That's the place on the last video that I lost sight of a problem, I think. All right, I'm going to go left to right. I'm going to build off of 4, so x minus 4 plus 7. How do I get from 7 to 1? I go down 6. How do I get from 4 to 9? I go up 5. Vertex, x minus 9 squared plus 1. Quadratic change from 9 to -4 is -5, but the quadratic change is 25 units. So I have to get rid of that 25. And how do I get from 1 to 7? I'm going to go up 6. So that's that function. What's the exponent I got to put on top of a 9? Well, I got to take a square root, so I know it's a 2. I got to flip it, so I know it's a minus sign, so I'll put an equal sign there. And I know I got to cube 3 to get to 27. So that's my answer. Now, how do I get it? I start by looking at 9x equals 1 over 27. 9 is 3 to the 2x, and 27 is 3 to the minus 3. And it sure looks like 2x equals minus 3. Oh, there's your minus 3/2. All right, now I'm doing Pythagoras. All right, so I'm going to look at this and I'm going to say, hey, x squared has to equal 20. X squared plus 25 has to get me 49. All right, so 49 minus 25 means that this has to be 24 units. And so the square root of 24. That's that x value. Square root of 24. Right? Because if you square that, You get 24, you get 25, you get 49, and you can visually see Pythagoras going to work. And if you know that, then you can build a triangle and say, how far is it from 3 to 7? 4 units. How far is it from 2 to 3? 1 unit. Then there's your z. And that's going to be 16 plus 1 square root. So that's the square root of 17. 1/3 to the 3 gets me this quantity. So 1/3 cubed. 1/3 times 1/3 times 1/3 is 1/27. And that's now a true statement. I'm looking for a couple of values. Maybe I'm asking to graph. I see a square root function. I see -4 gets me the smallest square root. And that gets me 9 units because there's a 9 over there. And if I'm going to get rid of 5, then this had better become 21. 21 plus 4 is the square root of 25. 5's cancel. 7 plus 9, 16. So I can see that 21 gets me 16, and I got a quick graph. If I understand the conversion process, right? What I need is the square root of 25 for that to cancel. That's why I pick 21. 7 plus 9, 16. Hey, gonna get up to breakfast before 7:30. If I hurry. And I've been taking too much time with each problem. All right, so writing the product. I gotta do what I did over there. It's a factoring problem. What do 5 and -10 have in common? The number 5. What do 8 to the 9th and 8 to the 6th have in common? 8 to the 6. There's 6 factors of 8 and 8 to the 9. X to the 4 and x is what they have in common. Now I gotta get back to the first term. I need a 3 to get 15. I need 8 to the 9. I got 8 to the 6th. I need 3 more. I need x to the 4. I have 1x. So I guess I need 3 more. Then I got to get back to -10. 5 times -2 makes that. I need 8 to the 6th. I already have it. I need x. I already have it. I'm done. That's that factor. All right. Exponential function. I'm just going to write this really quickly. I see 3. I see 11. I see 18. Then 3 plus 15 is 18. 1920. T minus 1920. How many years? 9 years. Plug the numbers in, look how it works, and go like this. And if you do, we're almost doubling. You're going to get a graph like this because we could put another number in here, and it's this distance from 11 to 3 is a change of 8 units. From 11 to 18 is 15 units. So my first differential is 8. My second differential is 15, which means I had to multiply 8 by 15 over 8, which is almost doubling. So my next one's going to be about 30 units above 3. I'm going to be near 33 when I pick what number? 9 units, so 1938. There's 9 units. So I'm going to get 30 plus, I'm going to get near 33. Let's see how it works. 1938 minus 1920, 18. Oh, what a coincidence. A multiple of 9. So I got to double this. I got to square this. I got to do 15 over 8 times 15 over 8. Okay, those 8 cancels. I get, I think 225 divided by 8. I think that's what that is. And then I got to add 3, which is 24 over 8. So there's my 249 over 8, I think. And I'm telling you that's about 33 when you multiply that out. 30 times 8 is 240. So hopefully you can trust the mechanics of that. All right, so now back to SAT work. Squaring this, I'm hoping you're getting better at binomial squaring. I got to double that product, minus 42i, and I got to square that. 9i squared, always positive at the end and the beginning when you square something. And the middle term is simply double the interior. But you go ahead and do it out if you want, prove that it's true. You're learning this. Go ahead, do it out. Let's see you get that. What does I squared do to 9? It changes it to -9. And so 49 minus 9 is 40 minus 42i. All right, that one's done. Not pausing the video, I hope. What am I doing here? I'm solving. So if I'm solving, I can just do the inverse operations, easy to hard. Addition becomes subtraction. Division, multiplication by 3 becomes division by 3. Logging base 5 becomes exponentiating, and that's the exponent. Remember, logs are exponents. And as soon as I move this and I move that, I've got an exponent equaling an exponent. We got it to 1, right? And 5 to the 1 is the inverse of that, leaving x minus 5. So I have to add 5 and I get 10. Can I recreate what I had? I think I can. I think that was a 3. Put a 10 in. 10 minus 5 is 5. What's the exponent you put on top of a 5 to get a 5? That's what this discussion was about. It's a 1. 3 times 1, 3 plus 3, 6. Okay. Finding the roots. Well, I'm hoping that you can sharpen up your thought processes. The roots. Well, I know 8 doesn't work, but I got to move to the left and the right in order to get to 0. I have real roots. There is an intersection where y equals 0. Roots are setting to 0. And I've got to move 3 units up, but I'm multiplying by 2, and I'm taking squaring. Well, I think those are my roots. A whole lot easier in the quadratic formula, isn't it? Yeah. So what did I do? Well, I put it in graphing form so many times that I eventually saw it. What the heck am I working for? Okay, so that's the graphing form for that picture. So what are you going to do? Subtraction 3, multiplication by 2, boom, boom, squaring plus minus square rooting, boom, and adding 8. I mean, all the numbers are there. Why not just take them, put the thought into it, do this again for a couple of days. And then you can find quadratic roots a whole lot easier in most situations. I very rarely use the quadratic formula anymore, ever. It's cumbersome. But I'll show you where it comes from at some point. All right, x squared minus 8x plus 7. Well, I can see that's factorable. X minus 7 times x minus 1. All right, so I can see my critical numbers are 7 and 1. Yeah, we'll talk about inequalities later. What do I have here? Well, I count the m's. 5 and 1, that means it's really 4. Right, m to the 4. So let me write that better. Trying to sort this stuff out. And if I do that 3 times, I should get 12. And this question is asking, what do you put on top of m to get m to the 12? I hope you know it's 12. So that was the answer to this problem. What's the answer to this problem? Pause the video again. I hope you say 4. And I hope that 4 explains to you what this question is all about. 2x squared minus 8 equals 0. Almost getting there. Well, when you got just one variable surrounded by mathematical operations, do the inverse. Subtraction of 8 becomes division, addition of 8. Multiplication by 2 becomes division by 2. And square rooting requires a plus minus, and it's going to take you weeks to learn that. I used to have a technique for doing it, sneaking up behind people and screaming, but I did that to a poor fellow who had a concussion. Never did it again. Good thing he was a buddy, soccer player. I was a coach at the time, and so we had a good relationship, but I didn't know he was concussed. All right, so x squared equals 9. There's x squared equals 9. I hope you see there's a positive and a negative answer, 2. 7i to the 23. I haven't seen this problem before, so I better do it out. Let's do it out over here. I have asked you to memorize that I squared equals -1. So textbook has a pattern of 4. I don't do it that way. I want to make sure you know that. So I'm going to have you write I to the 23 in terms of I squared, and it becomes 7. I squared. How many times does 2 go into 23? 11 with a remainder of 1. This is awkward at the start, but it's got some good stuff to it. 1, it makes you learn your rules of exponents. 2 times 11, 22, plus 1 more makes 23. 3, you really are going to be working with sign changes quite a bit later on in the term. So does -1 stay -1, or does it become +1 when I do -1 times -1 times -1 11 times? It stays as a -1. And so what is 7i to the 23? Simplified, -1 times 7, -7 times I. So this became -7i. Is it simpler? 1, 2, 3, 4 strokes of the pen. 1, 2, 3, 4. 1, 2, 3, 4, 5. Took me 5 over there. Oh, the rotator cuff. I had to write an extra. Ooh. All right, name that tune. What tune? I erased it. How stupid. Well, let me give you there's a name that tune there. Name that tune, name that tune. What don't I see? I don't see this problem. X equals 5. Let's get some random numbers. Let's make this 8. Let's make this 2001. Great year. And now let's go to a better year. Better year was 1703. Yeah. 1703. Tremendous year. Let's go to 15 and let's go to 2025 today, this year. All right, so what's that equation? Not going to make a whole lot of sense to you yet, but I'm just going to do the mechanics again. We start with y equals, let's take the first y. How do we get from 1703 to 2025? 322 years. Okay, if I made a mistake, let me know. It's a logarithm. X equals 5, so x minus 5. To get that asymptote in play, I'm going over 3 units. And then I'm going over 10 units. So the base of that is 10/3. All right, so plug a 15 in to check it. 15 minus 5 is 10, so I get 10/3. What exponent do you put on top of 10/3 to get 10/3? That's the number 1. And then you got those years added to get that. Yeah, I'm running out of gas. Running out of gas. All right, what's this equation? It's absolute value, x minus 5 plus 2. How do I get from 2 to 17? Up 15. How do I get from 2 to 9? Oh, that's changing x, excuse me. I told you, changing 9, 5 to 9, 4. I was fine. 2 to 17, 15. All right, and that's that graph. 2x squared minus 20x. I see cup shape up. I see that 0 and 9 is on the decreasing side, so I know that my minus b over 2a is going to be positive. So minus b, 20 over 4. Correct, it's positive 5. I know if I put a 5 in here, I get minus 100. If I cut it in half and add 9, I get minus 41. But I will take the time now to plug in 5 just to show you the shortcut there. So if I put 5 in, I get 50 minus 100 plus 9. Yes, that was minus 50 plus 9. Right. Woo! Okay, so got to get that one. So I can see 2 points. I can see 4 gets me 3. That minus 3 could have come to the other side. Might look more familiar in our class if we did that. So I can see I get a 4, get a 3. My x is changed by 2, so a 6 gets me 8. And there should be no reason that anybody can't go over 4 up 3, over 6 up 8, and connect those 2 dots. All right, we'll take more time with that as we go along. I don't think it's going to be troublesome, so we'll deal with it during the term. Y equals 5, so what's this equation? This equation is I've got to add 4 to get to 9. Next time I don't add 4, I've got to get to 13. And from 4 to 13 is 9. And I want to get rid of 1900, so I'll do t minus 1900. And how many years have elapsed? 50 years. All right, and we'll keep doing that in class and talk about it. And I will talk about it hopefully future videos. Okay, it took me over a half an hour to do that. So at least you got some practice. If you don't have a chance to get in a classroom, you got some practice if you take advantage of it. All right, ciao.